Okay, lesson 7.3, similar triangle notes. So we've already looked at similar in the previous lesson. We talked about similar is when corresponding angles are congruent and corresponding sides are proportional or in the same ratio. So right here, we're asked to make a similarity statement. So one of the things that you want to try to do is try to identify congruent angles in helping you make the statement. So in other words, we know those two angles are congruent because they are vertical. And then we look for proportional sides. Now, here I have an 18. I have to figure out which one the 18 goes with. Well, 18 goes with 78, and the reason it does is because 18 is smaller than 27, and here 78 is smaller than 117. So that means the two smaller ones in the two triangles have to go together. So I have to check to see if they're proportional to the other two sides, 27 and 117. So I do 18 over 78. See if that equals 27 over 117. Now remember, we said you could do this by either cross multiplying and seeing if they're equal, or doing math frac and seeing if you get the same ratio. So that's what I'm going to do. So I'm going to do on the calculator 18 divided by 78 math frac, and I get 3 over 13. And then I do 27 over 117 math frac, and I get 3 over 13. So these are similar. Now, I have to write my similarity statement. So in the small triangle, I'm going to go L, B, C, and see if that matches up. Well, no, because that would go L, N, M. I've got to make it match L, M, N. So if we go to the big one first and trace it, L, M, N. L, M, N. So then the other one would go, since L to M was 117, L to C is 27, and those two sides went together back over here in our ratio. So that would go LCB. So down here I'm going to write triangle LCB. Now, what's the reason? Well, if you look at our triangle, we have side, angle, side. Side, angle, side. So the reason, when it says how you know they're similar, it's going to be SAS, but here we do similarity. Okay, we're not doing SAS for congruent like we did earlier when we were looking at triangles congruent. So this is SAS similarity. Okay, now let's go to the next one. Alright, so let's look. 6 is the smallest side in this triangle. 12 is the smallest side in this one. So if I do 6 over 12, that is 1/2. Okay. What about 7? 7 is the next smallest. 14 is the next smallest here. So 7 over 14, that would be 1/2. Okay, then what do we have? 10 is the biggest one here. 20 is. 10 over 20 is 1/2. So they're all 1/2. So these are similar. Now I do my similarity statement. So I go over here. It says TUV, TUV. So I went 14 to 12. So here I went blue to red. So here I need to go blue to red. So that's going to be MLK. So down here would be triangle. Oops. So now right here, MLK. I don't know what's in gray, but MLK. Alright, now what's the reason? What do we have here? We have side, side, side. Side, side, side. So the reason here would be SSS, similarity. Again, we have to put that similarity symbol beside of it. Alright, so now that we've kind of done a couple, we'll go a little bit faster here. So again, you've got to check. It says state if the triangles are similar. So you always have to check to see if they are first before saying anything else. So here we have S, 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 side, 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 but I've got to check my proportions again, my ratios. So here, 9 is the smallest side, and this one 7 is. So that'd be 9 over 7. That does not reduce. Here 12 is the next one. Here 9 is the next one. 12 over 9. Well, that one does reduce. 3 goes into that. 4, 3. Well, those are not equal. So these are not similar triangles. Can't write a similarity statement if they're not similar. Okay. Let's try this one. Now, since these two sides right here are parallel to each other, then we have our corresponding angles. So this angle is congruent to this one. This angle is congruent to this one. And you might be looking, you're saying, well, where are the two triangles? Well, here's one where I used to tell students all the time, separate the picture. So you have E, H, G. E, H, G. There's the small triangle that's on the top. One arc, two arcs. Then where the other one is the big triangle. E, C, D. One arc, two arcs. Okay? And actually, if you look up here, this angle is the same in both triangles. It's in both triangles. So these are definitely similar. These are similar by what is known as AA similarity, angle-angle. Now, we didn't have an angle-angle congruence. Remember, we had angle-angle side, but to be similar, all you need are two angles. And the reason is because if two angles are congruent, then what we just pointed out, the third angles have to be, which means the triangles will definitely be similar. Now we have to match them up. So in the big triangle, it goes E, D, C. That's our statement right here. So this one would go E, G, H. E, D, C, E, G, H. So we come over here and write triangle E, G, H. Okay, let's keep going. So again, here we have vertical angles. And then since both of those two angles are 82, then we know these two triangles are similar already by what we just said a second ago, AA similarity. Because if two angles are equal, then we know the third one's going to be. We look at our similarity statement, DCB. So DCB. So red arc to 82 to no mark. So I need to go red arc to 82 to no mark. So that's DQP. DQP. So triangle DQP. Here, it wants us to find the missing length. So what we know are the triangles already similar. And the reason we know that is because it gives us a similarity statement. So I have to match them up. Now this first one's actually pretty easy, because if I pay real close attention here, both of those are 40, which means these two are going to have to be equal in this triangle, which means if this one right here is 12, then that one right there also must be 12, because this triangle is an isosceles if those two sides are the same, which means this one's going to have to be isosceles as well. So we didn't have to do any proportions there. Now it doesn't always happen, like in this case. Okay, so in this case we are going to have to do our proportion to find the missing side. Now, what you want to do is read your similarity statement so that you know what goes with each other. In other words, this 21 is side LR, or RL. So we're going from L to R. So that goes with, if we come over here in the other similarity statement, LN, which is right here, which is the 56. So the 21 and 56 go together. So I come over here and I write 21 over 56 has to equal. Now, what goes in the other? Well, the question mark, or my variable, I'm going to put x, has to go on top. Why? Because it's in the same triangle as the 21. So down here goes the 88 because it's in the same triangle as the 56. So 21 question mark go together on top, 88 and 56 go together on the bottom. So now we cross multiply, and you definitely want to have a calculator here. So we have 56x equals, so 21 times 88 is 1,848. Then you divide by 56. So then you get x is 33. So the missing side length would be 33. Okay. Same sort of thing here. So again, here's another one. If we pay real close attention, that's an isosceles triangle. So that means this one is also isosceles, which means this has to equal that. So I have, now again, you could do a proportion, but you don't have to here. So negative 1 plus 16x has to equal 143. Now we solve the equation. Add 1. That's 144. Divide by 16. So 144 divided by 16 is 9. And we don't have to plug back in because we know it just said solve for x. However, it's not a bad idea to plug back in because we know that if we do, we should get 143. So if I come back up here and plug in, and I do negative 1 plus 16 times 9, I get 143. So that proves that 9 is correct. So using similar triangles, real quick, before we end this, I want to review what are the ways to prove triangles are similar. So we have SSS similarity, SAS similarity, and AA similarity. Okay, so those are the three ways to prove triangles are similar. Triangles congruent, I'm going to write it in red over here. We had SSS, SAS, ASA, and AAS. Now, the reason there's only 3 with similarity is because if we look right here, both of these have 2 A's, and those correspond to that. Okay, so that's the reason there's only 2 or 3 ways to prove triangles are similar, but 3 or 4 ways, to prove triangles are congruent.